Hello friends, welcome to SR Physics Academy. Today we are going to discuss about electric potential difference. Here, before going into the concept of electric potential and potential difference, let us review the relation between force and work. So here the image shows a region of space where the electric field is constant. Here a point charge Q in this region experiences, and the electric force is given by what is that, F equal to QE. So let us assume that the charge move from where from point A to point B, and the distance is what we call delta x. Let the direction of the displacement, the direction of the displacement from A to B is parallel to the electric field. So this electric field direction and electric force direction both are parallel. So when from point A to point B, what that is the charge moving from one place to another, some work has done. That work done, we can say that electric force into displacement, here delta x, F into delta x. So next, here now we will discuss about what is potential difference. Let us assume that a point charge Q, the point charge is Q, is also known as source charge, located at a point O. Now let us bring a test charge Q naught from infinity to a point here B, which lies in the electric field of the source charge. So this is the electric field. We consider as this area is the electric field is there. When the test charge is moving from B to A, that means from point B to point A, further within the electric field, a work AB has to be done in moving against the repulsive force exerted by the charge Q. So in this case, see here this is plus Q charge. Here also plus Q charge. If the minus Q is there, we know that it will positive and negative, it will attract. But in this case, this is positive charge. Here also it is a positive charge. So what happens? It will repel. So here what we have to do some work. So from point B to point A, how much we have done? Some electric force. That is the force and distance it is moving. So we can say that the work done we have done. So work done is nothing but what? Electric force into delta x. But in this case what happened there? It is the positive and what is that? This both are parallel direction. But in this case it is the again this the reverse direction. So the potential difference between 2 points in an electric field is defined as the amount of work done in moving a unit positive charge from one point to the other against the electric force. It's clear? Now VA minus VB. The VA, how we can read it here? VA equal to potential at A. Here VB means potential at B. So what is VA minus the difference between? The difference between one point to another. So that means how much work we have done here. So the work done in bringing a unit test charge from point B to point A. Now how we got it here? VA minus VB. Let's discuss. Now, here what is the point starting point here? B, that means VB. Here starting, that means initial point, and this is final point. So we know that it is the, what we called it is that, oh, this is final, when we calculate time, final minus initial value. Is it? Same type here also. What is here? The potential initial. Okay, potential at B is initial point, and when it is moved from towards here, that is the final point here, that means VA. So then when we will calculate time, how we will calculate the difference? Final point minus initial point. So here VA is the final point and VB is the initial point. So we know that it is the difference between, means VA minus VB equal to, okay, how we can write it? Work done, WAB by Q naught, charge. Okay, how much we have done work by Q naught. Now we are going to discussing what is the unit of potential difference. So here SI unit of potential difference is volt. That we, this is the written capital B. It has been named after the Italian scientist Alessandro Volta. Now the electric potential is nothing but work done by charge. Now we have to know that this is the unit. Okay, so before we know that electric potential equal to nothing but work done by charge. So what is the unit of potential here? That is volt, V. Okay, that is 1 volt. 1 volt equal to work done. In small class we learn about that. Work done equal to unit is joule and charge is coulomb. Now, so we can also write it 1 joule, we can write it Newton meter, and coulomb is, it is the denominator, so when it will go to numerator, coulomb minus 1. Then this Newton meter also we can write it joule. So finally 1 volt equal to 1 joule coulomb minus 1. Now that is a defined 1 volt. In words, how to write it? Okay. The potential difference between 2 points in an electric field is said to be 1 volt of, okay, we know that 1 volt of 1 joule per 1 coulomb. So 1 joule of bar has to be done moving in a positive charge of 1 coulomb from one point to the other. Okay. So against the electrostatic force. Okay, clear? So that it is nothing is there. 1 volt equal to 1 joule by 1 coulomb. They are written in the words statement. Now, what is electric potential? The electric potential at a point located far away from the charge. So see here this image. What it is there? It is the charge. It is the infinity. Okay. So far away from the charge taken to be considered as 0. So how we can write it as a definition type? Electric potential at a point in an electric field is the amount of work done. Okay. The amount of work done in moving a unit charge from infinity to that point against the electrostatic force. So here against the electrostatic force means we know that electric field is this direction and we have to charge from this direction. Okay. So here from where infinity to that particular point. So here, so now we know that here we can write it. So this consider as how we know that. So see this image there, this point. Okay. So the point B lies at where infinity. Then we know that B we can call this potential at B. So VB equal to 0. So that we can write it here V equal to VA, because here VB is cancelled. Okay, that means 0. That means VA equal to work done by Q naught. So SI unit of electric potential is volt. Then same only how we, that is there, how we written 1, okay, volt equal to, how we written 1 joule by 1 coulomb. Okay. So how we are written, it is there here defined in the word statement. The electric potential at a point in an electric field is said to be 1 volt if 1 joule of work has to be done in moving a positive charge from 1 coulomb from infinity to that point. Okay. So against the electrostatic force. So you have to remember there, potential difference means it is not coming from one point to another point. Okay, but here from infinity to that another point. Okay, clear? Let us discuss some example here. A charge of 50 Mc is moved from one point to another. That means from A to B, the voltage at A is 50 kV and voltage at B is what, 30 kV. Find the work done by the charge. So here, what is the solution as given? See, charge they are given. What is that? 50 Mc. Okay. It's moved from one point to another. So it is clear. That means here VA. Okay. Potentiality A given, potentiality B given. So VA minus VB equal to 50 kV and 30 kV. We will get 20 kV. Now what we have to calculate here? Find the work done. Okay. So we know the formula here. Electric potential equal to work done by charge. Okay. Now what are the given data is given? Electric potential is given and charge is given. Now what we have to